So welcome to our Graduate Student Council Distinguished Seminar, Distinguished Speaker Seminar. My name is Pindera, and I am very pleased indeed to introduce today's speaker, Professor Marcio Cavalcante of the Federal University of Alagoas in a sunny coastal city of northern Brazil. Professor Cavalcante holds bachelor's and master's degrees in civil engineering from the Federal University of Alagoas, which he received in 2004 and 2006, and a PhD in civil engineering from the University of Virginia, which he received in 2012. So it's been some 7 years ago. His area of expertise lies in computational modeling with a focus on structural mechanics and optimization, as well as micromechanics of heterogeneous materials. He works on a wide range of topics, including micromechanics and homogenization of composites and functional graded materials, as well as the development of novel computational techniques for this class of materials. His contribution to the development of the finite volume theory used in the analysis and design of advanced composites and advanced materials has been recognized in a recent review article that puts him in an elite group of researchers throughout the world. And let me share this figure that appeared in this article, where you can see that Professor Cavalcante is already on a world map. Congratulations, Marcio.
Thank you, Professor.
So, in addition to his numerous research and teaching activities, Professor Cavalcante also holds a number of administrative positions, and these include coordinator of the Energy Engineering undergraduate course at the Federal University of Alagoas, vice coordinator of the graduate program in civil engineering, coordinator of the project of energy efficiency and mini-generation at the Federal University of Alagoas. He's also a professor of the graduate program in materials. He's a full member of the State Renewable Energy Committee, and this is at the state level, correct, Marcio? Yes, State of Alagoas. Yes. And also he is a substitute member of the State Council for Energy Policy. So today his talk describes the project on energy efficiency and mini-generation at the Federal University of Alagoas that he leads. So let's please extend a very warm welcome to one of our own, Professor Marcio Cavalcante.
Thank you very much, Professor. It's it's a big pleasure for me to be here with you again and to have this opportunity to show something that I have done in the last 12 years since I got my PhD. And it was a big pleasure to work with you and to live in Charlottesville, to have that good time learning and evaluating as a person, as a professional, at the University of Virginia. That was a very good time for me. I would never forget.
Thank you.
And I would like to start sharing my presentation that I prepared for you guys. And somebody needs to give me the permission to do it.
Garrick, can you?
Yes, I'm doing it.
Okay, thank you.
Okay, Marcio, you're good to go.
Thank you very much.
If you can, please turn up your mic a little bit, your volume.
Okay. You can hear me now? Good now?
Yes.
So it's okay?
Yes. Yes.
Everybody see my presentation?
Yes.
Yes.
Yes? Okay. Yes. So let's start. It's a pleasure for me to be here with you in a graduate seminar I would be able to participate as a student, as a PhD student, before 2012 when I got my PhD degree. And the topic is Project of Energy Efficiency and Minigeneration at Federal University of Alagoas. It's supported financially by Equatorial Energy Company of the state, has administration, financial administration by Fundeps, a foundation here of the state. And this project is part of many projects that we are having in our university, Federal University of Alagoas. And it was a pleasure to me to be the coordinator of this project. I was chosen by the university administration at that time. I'm going to start with a short description of my life, if you allow me. I was born in the countryside from a poor family, but a very happy family. And a city of Bom Conselho, it's like good advice in English. We have a strong Catholic way of life in that city. And here we can see some picture of me and my brother. I am this guy here. Let me show you. I am this guy here. And this is my younger brother. And that was a great time of my life. I lived in that city until 10 years old. And this is the house where I lived with my parents and my 4 brothers and my sister. Here it's another turning point of my life. When I started to live in Maceió, when I was 10 years old, my parents decided to go there to live in Maceió. It's a big city, it's the biggest city of the state, Alagoas. It has, as Professor Pindera said earlier, we have very nice beaches and beautiful beaches here. And I put here some pictures of a big day of my life when I got my master's degree, and under supervision of Professor Severino, this guy here. It's a very nice guy, and I had the opportunity to meet him earlier in my civil engineering undergraduation course, and he was my advisor during my undergraduation course and in my master's degree course also. And this is the committee, Adeildo, Professor Adeildo from the University of Alagoas also. That was a good day and very important day for me. And this is where Maceió is located. It's right in the coast, as Professor Pindera said earlier. And here we have some pictures of my life in Charlottesville. That was a very nice time for me. And Professor Pindera was a very good advisor, not just as a professor, but as a friend too. So he was able to give me a lot of advice for my professional, for my professional life. And also he was always worried about me and my wife, about my family. If we were doing well in Charlottesville, we were foreign, so to have this kind of care from Professor Pindera was very important to us. And here we have some pictures. That day, I felt a little bit important because I was with the dean of the university. Here is in Washington, D.C. That was a good day for us. That day, I think was the first time that I went to Washington, D.C. with Professor Pindera, my wife, and Molly, Pindera's wife. And here was in Jamestown, a very, very good day because I got to know some history of the United States, and that was very important to me. I was in that important location for you. And that here I have a picture of a very important day. when I got my PhD degree, and I'm here with Professor Pindera, and Chu, Wana, some of his students, and that was a very important day to me. And after that, I would like to talk with you about the motivation for this project. First of all, the Paris Agreement in 2015 was a very important day to the world, to our country, because in that day, those countries, almost 200 countries, decided to invest in a way of life to protect the environmental. So that was a good day, important day for all of us. And I could also talk about some countries that have already set deadlines to end the production of fossil fuel cars, like Holland, Germany, India, and United Kingdom. And that is very important. This is going to be a turning point for all of us. Because if you have a car, electric car, doesn't make any sense to recharge that car using fossil fuel. So it's a perfect marriage, renewable energy with electrical car. So that's going to be a turning point for the humanity. And another day that I would like to talk about was the day when German parliament decided to close all the nuclear plants by 2050. And that was a great decision. That decision was motivated by the Fukushima event. Part of the population liked that, to have those nuclear plants closed, but just after that event, that accident, they decided to close all the nuclear plants and to invest a lot in renewable energy. And the goal is to have 80% of the energy matrix from renewable energy up to 2050. And here we have some pictures, important pictures that show us how the renewable energy, solar, photovoltaic, and wind energy, wind power plants, how they are growing around the world. In 2010, we had about 40 gigawatts. And in 2019, that number increased a lot. More than 600%. So this shows us how the solar photovoltaic, this is the installed capacity, how the solar photovoltaic is increasing, and those capacity and those installations, those plants. And in the right, you can see also how the wind plants also are growing and growing a lot. In 2010, we had about 180 gigawatts. And 2019, 9 years later, we had almost 600 gigawatts. So this is a lot more. And this shows us clearly the way the world is thinking about how to produce, how to generate energy. And we have here one of the reasons. The technology is decreasing the price of with a big amount, almost 80% between 2010 and 2015. And this is one of the big explanations for this technology being used and employed a lot by commercial environments and also for the people. And here we have a very nice project, a Google project, called Project Sunroof. The idea is to use the Google Maps to evaluate how much energy your roof the roof of your house can produce. And this would be great. This is still not working for in all the cities around the world, but at some point, Google will do it. It's going to do that, and we're going to be able, with a simple software, to evaluate how much energy we can produce in our roof and how much money we can save with this. And I have here a little video about that project from Google.
So there's this giant power plant in the sky, and it's creating free energy for anyone to catch. But most people aren't catching it because even though it could save them money on their electric bills, getting started can be pretty frustrating. There's all this stuff to figure out, like how many panels do you need, who's going to install them, how much would you actually save, and how do you tell if your house even gets enough sun? A lot of people ask Google these kinds of questions, so we started looking for a better way to give them answers. And that's when one of our engineers got an idea. If people are getting lost trying to find answers about solar, why don't we give them a map? We could take the information that's already in Google Maps and use it to show how much sunlight falls on a roof. Then we could combine that with all the other stuff people need to figure out and create kind of a treasure map of solar energy. It could show you how much solar power your roof can generate and how much you could save. Then it could even point you towards an installer in your neighborhood instantly. It's an idea we're calling Project Sunroof. And right now, we're just starting with a few places, like Boston, where the Sunroof team is from, the San Francisco Bay Area, where Google is from, and Fresno, where one of our engineers' mom is from. Pretty soon, it'll grow to include the entire country, and maybe even the whole world. That way, anyone, anywhere can start catching energy from that power plant in the sky.
Okay, everybody could listen well this video, the audio of this video. Hello, everybody is listening to me?
Yes, we can listen.
Okay, nice. And in Brazil, in terms of Brazil, I can talk about some points, important points that show that Brazil can be or can play a big role in terms of renewable energy, because we are doing this a long time ago, especially using the hydropower. Because we have 64.9% of our electric energy matrix from hydropower. But we are also investing in wind and solar. And this is growing very fast here in Brazil too. And comparing Brazil with the rest of the world, we can see here that when considering the supply of electricity, in Brazil, we have 83% of the electric energy matrix from a renewable source. In the world, this indicator is only 26.7%. So we are much ahead, and we can do well, and we have a lot of potential here. Brazil's insolation level is 50% higher than Germany and China, countries where we have the biggest solar plants in the world. And we had, incredibly, energy crisis recently. And we are activating our thermoelectric plants that use fossil fuels. And this increases a lot the energy price for the people. So when we got in that situation, the government decided to invest a lot in wind farms in the south and northeast region in the last years. And also they regulated the possibility to install a microgeneration of electric energy in the house, basically using a bidirectional meter. So we can produce energy and to send that energy to the electrical network. And also we can use the energy from the electrical network. And this is a big difference, and that made a big difference. And the people, since that regulation, they start to buy those solar panels and to install in their house. In Brazil, up to 2016, our installed capacity of solar photovoltaic was very little, very little. And we are just starting, but it's starting very fast. So we realized in 2017, up to now, that to install those panels can save a lot of money, not just for the house, but for the industry and for the commercial environment also. In terms of wind power, this is a government investment, federal investment. And we started with, in 2010, with about 1 gigawatt. In 2019, we got almost 16 gigawatt. That's a lot. It's an exponential increase. The northeast of Brazil, where I live, we had here the biggest potential in the country in terms of solar energy, because we have a lot of insolation. And this map, it's a map that shows this, the insolation around the country. And here we can see that the northeast is where we have the big amount of insolation. Also in the northeast, we have a great potential to the wind power. And this shows the average wind, the average annual wind around the country. And we can see also that in the northeast of Brazil and also in the south, we have a lot of potential to produce, to generate energy from the wind power plants. And here I have a video about where I work, the campus of the Federal University of Alagoas, where I work, and some of the projects that we're investing, that are coordinating a complex of buildings where the energy engineering will work at some point. So the subtitle is in Portuguese, but during the video, I'm going to explain a little bit for you. So we are the Northeast state of Alagoas, Federal University of Alagoas. This is one of our campus, okay? It's a big campus. This is where I work. We have a big extension of land. At the beginning, we have most of the buildings where we can see, where we can find the classrooms, the labs, everything else, the library. But most of the land are used for experiments, because here we have agricultural experiments. We have this course in our campus. So we have little farms, artificial farms, where the professor and researchers can experiment different ways to take care of them. And most of the land is still not being used by the academic community, because it's very big. It starts in the highway, in a highway, and finishes in a little river behind. We have this small lake and a small village with house, with people that used to work in that place, and they are inside the campus. This is our most important program, a project for sugarcane development. Most of the variety of species of Brazil are developed here. 70% of the sugarcane in Brazil species comes from here. And this is where the students stay. We can see some buildings of the classrooms. We have a lot of trees. It's a very good environment to work. And this is one of the buildings where the professors of the energy engineering work. And this is a small solar system that we installed there. Later, I'm going to show a video about this installation. Okay, this is a station for weather measuring. And this is a small hydropower right behind the campus, where the students can go to see how things work, the machines, and how you can control this kind of technology and the basis of this technology to generate energy. And in a month, that small hydropower can generate 600 megawatts hour. And this is a dream. The construction is going on, and the estimation to have this done by the end of the year. And this is a complex of buildings where the energy engineering will work with classrooms, rooms for the professors, labs. And we are in a difficult time, but we are building this complex to this important course, and also for the electrical engineering. Those guys will be able to study and to do his work here in this complex too. Okay, the idea is to have solar panels and a wind power, a small one generator, in a way to have self-sufficient in terms of energy. And this is the project that I'm coordinating. The idea basically is to save energy, to save money to the university. And in that time, we were paying 460,000 reais by month in electricity. And the idea of the federal government was to invest in the federal education institution in order to save money and to show to the society how to apply this kind of technology. Basically, we have here efficiency projects and a mini photovoltaic solar plant to generate energy for the main campus of the university. So in this project, one of the ideas is to replace more than 1,500 fluorescent lamps with LED lamps in the main library. Why the library? Because in the library, most of the time, those lamps are turned on. And the idea is to improve the quality of the library lighting, reduce the cost of maintenance because of the LED lamps can survive a little bit more, and disseminate energy efficiency projects to society. So the idea is not just to replace those lamps, but also to show how much you can save with this kind of project. It's also the goal of this project to build a solar plant with 360 solar photovoltaic panels and 130 kilowatts peak of capacity. And we're going to be able to generate around 700 kilowatts hour a day, resulting in about 20,000 kilowatts hour per month. And the project of this solar plant involved a lot of people. I coordinated because I'm a civil engineer and I can do it with no problem this. And here we could involve a lot of professionals And we have here different engineers with different backgrounds, also architecture, and would be able to project something with the intention to have a standard, a reference to the society, how we can do it, to have a situation or a project in terms of energy production from solar panels in a very, very efficient way. Thinking about everything, not just the system itself, but also about all the civil projects that are involved, because it's just not about the solar system. And here we can see a video about this project. It's a 3D simulation. This construction is also going on, and the idea is to have this done by the end of the year. This is the main entrance of our university, of the main campus. And the idea is to have this solar plant very visible, not just for the academic community, but for the people that is passing in the highway in front of our university. And we thought about everything, because the idea is not just to generate energy, but to have here a lab, an external lab, where the students and the researchers can measure at real time how much energy the solar plant is generating, and to compare with the environmental situation in terms of humidity, temperature, insolation, and everything else. And we project the structure that support the panels, because we didn't find good options in the market, so we decided to project. And we have this little house. The idea is the students and the research stays here, close to the solar plant, measuring everything. We have here the inverters and a storage room when we can put some panels and materials and equipment to clean the solar plant, and to have an environment for the students to stay. And the roof is going to be very important to us, because the idea is to have visitations, to have some students from the high school, from other universities, to see our solar plant, how it works, and how we can do better in terms of project installation. Here we have a prototype of the panel support structure. I designed that structure. And the idea was that structure to be able to regulate, to change the angle in the way to have more insulation in those panels. And here we have my students, my colleague, one of our professors, and the idea is quite simple. It's a simple mechanism, but we didn't find in the market, as in the industry, not close to us. So we decided to design and to manufacture in the university. And here we can see the installation of a solar photovoltaic system in that campus. I invited my students, I invited other professors, so we can do it together, learn together. The structure was done. It's a steel structure with a concrete base, and those students could participate of this moment with us. And we could install the panels, install the cables, the inverter, And we have 20 photovoltaic solar panels, and we have this is a 6.6 kilowatts peak power solar system. So we are using this system basically for our classroom and also for research, comparing the environment measuring with the energy generated by this system in terms of humidity, temperature, insolation, and everything else. And this project also involves the idea to develop and innovate in this area. And we have scholarships for professors, students of 3 different courses: civil engineering, computational engineering, and energy engineering. And we are having meetings, 2-3 meetings a year. That project is starting to 2018, and we're still going on. We are going to finish this project by the end of this year with that solar plant done, and most of the research also done. One of the goals of this project is to develop a low-cost and non-invasive supervisory system for measurement and detection of losses and diagnosis of the electrical grid. The idea is to install a prototype developed by our researchers in the entrance of the local electrical grid of the building, and using inference techniques and the composition of electrical sign to know which equipments are consuming more energy, and also to detect some losses in the local grid due problems in the installation, in the cables, and in some equipment. So this is a kind of project. This is actually an efficiency project where we are able, based on those data, to decide what to do to improve the energy consumption of the building. Another goal of this project is to validate a computational simulation of the impacts in the electrical grid caused by the distributed solar photovoltaic generation. We know that those panels don't have any inertia. So if you have some obstacle coming through, we can have a lot of fluctuation in the energy production from those solar photovoltaic systems. And this is not good at all for the electrical network. We have some problems in countries like as Germany, where in some locations we have a massive installation of those solar photovoltaic systems. And in this sense, if you are having a lot of energy coming from those panels with no inertia in their behavior, this can be a problem for the electrical network. And we are doing research in this topic. We are studying techniques and trying to develop some technology to mitigate these problems created by this no inertial behavior of these solar photovoltaic systems. We have these problems in some countries, as I said, and at some point we are going to have this kind of problems in many countries, in many cities around the world, because those installations will be done in many houses, in many industries, and this is going to be a problem for our electrical network. And some technology, some techniques must be developed to solve this problem. And we are doing this also. And we have a little more of expectation from this project. One of them is to stimulate the university and stimulate the society to provide for those buildings houses and industry at all, to provide a label in a way to measure how well you are using the energy in your building. So we have already a program that we're able to classify those buildings if you're doing well or not in terms of energy consumption. And we take into account the architecture in terms of natural lighting, natural ventilation, natural air, and we also needs to take into account artificial lighting and artificial conditioner, and using those parameters to classify our house. If that house or that building is very efficient in terms of energy consumption. And unfortunately, although we have the program, most of the buildings in Brazil doesn't have that label, and that's bad. And in that little building of our solar plant, the idea is to have that label and to show the people what we can do in terms of architectural design, in terms of lighting design, conditioning air design, to improve the efficiency of the building. And that small building of our solar plant was designed to be efficient in terms of energy consumption. Another goal is to build actually a garage, but the idea is to have a solar parking, because the idea is very nice. Once we have a lot of insulation in our country, most of the people like to have those cars protected in a way to have a car not so hot when get in that car during the day. So those parkings can be designed not just to protect the cars from the sun, but just to generate energy. And that is a very, very good idea. And we're going to invest in this at some point. We hope to do it in the next few months. And another project that I'm involved as an structural engineer is Aggro Photovoltaics, combining photosynthesis and photovoltaics. Because we have a big problem with those solar plants, central concentrated, not in the roofs, but big solar plants, because you can have a lot of land, just use it for that. And that's not good at all. Not in every country can do it. Not every country has a lot of land to do it. So the idea here is to project a solar plant in a way that we're going to be able also to have farms below those structures, below those panels. And that's a nice idea. And some of the sugarcane farms in the Alagoas states, and also the state government wants to invest in this. And they provoked us at the academic to do something, to do some project for them. And we design a structure to have those panels installed. And the idea is not just to have a static system, but the possibility to change the angle in a way to have more energy generated by that solar plant. And here is a little video about that project, a 3D modeling of this project developed by us. So the idea is to have separated structures. So you can have many of those structures in your land, and you can decide also the distance between those structures in a way to have a good production in your farm, because the idea is to have the possibility to generate energy, but without compromise the farm. So we can decide the distance among those structures. We can also regulate the angle in a way to have more energy produced, generated in this farm, in this solar plant. And the farm is a sugarcane farm. We have a very strong investment in sugarcane in our state. And it's a traditional, it's historical in our state to have big farms of sugar canes. And the idea is to use those farms not just to grow sugar canes, but also to generate energy through our solar photovoltaic panels. And for this, we need a very high structure. This is about 7 meters high, so you can work below those structures without problems with your machines, vehicles, and everything else. So this is what I prepared for you. I'm open for questions. Thank you very much for your attention. Thank you very much again for the invitation. And I hope I got your attention and your interest in this kind of research. As Professor Pindera said, I'm an structural engineer, and I'm doing research in material science, in materials modeling, heterogeneous materials modeling, optimization, confined concrete, functional grade materials, and numerical methods for structural analysis. But in this project, I worked essentially as an administration guy. So I was able to united some of our researchers and some of our students from different courses, and I think we're doing well, because this is the first big project in those topics in our university. So thank you very much for your attention again.
So Marcio, thank you so much for taking time away from your very busy schedule to prepare this presentation. I wonder how much sleep you get each day.
Yeah, it has not been easy. I'm completing now 4 years in coordinating an undergraduate course. And right now, some of my colleagues invited me to coordinate our graduate program. And once I'm still young, I'm going to do it, Professor, and to collaborate a little bit more with our university, but of course, without forgetting my research and teaching obligations.
Right. So I'd like to open the seminar to questions. I believe that Professor Garrick Lewis has a couple questions that he posted to the chat. So questions for Professor Marcio. Number 1, what is the energy storage system for the solar power plant? So there are 4 questions. We'll go through each question. So the first question is, what is the energy storage system for the solar power plant?
For this solar power plant, we don't have a storage system. It's a grid tie on system. So we are using both energy from the solar plant and also for the electrical network. So we do not have a storage system.
Gary, do you want to ask the questions directly?
Okay, feel free.
Yes, sure. Thank you, Professor Pindera. The second question is, are the solar panels made in Brazil?
Unfortunately not. Actually, we had a guy in Alagoas that was very motivated to have here industry to produce those panels. But once he bought those industrial plants to manufacture those panels, he realized that that technology was not able to compete with China, with Germany, with Canadian solar panels. And he got a little bit in financial troubles because of this. But he's a big entrepreneur in our country. He's a big investor. So most of his money comes from civil engineer projects, buildings. So that was a problem for him, but that would be also opportunity for our students to work, to do research in that company, but unfortunately that didn't work at all. So basically most of our solar panels we are buying from China.
Okay. And then my third question is about the price of the electricity from the solar farm relative to the price from the grid electricity system. Do you have a sense of what the savings would be?
For this our solar plant, we estimate that solar plant will be paid by 5 years once we start to generate the energy. So we need for sure to invest a lot of money initially, but once that solar plant is paid, and the maintenance of this technology is little. This is the biggest advantage of this technology. We do not need a lot of maintenance, different of a wind power plant. So those panels can generate energy without a lot of maintenance, during 20 years, 25 years, 30 years. And in 5 years, we have that paid by itself.
Okay. My last question is not necessary because you said it's a hybrid of solar with grid electricity. And my last question was about what's your source for peak power on cloudy days or on days when you have, a lot of air conditioning use or on things like that?
Okay, during the day, the peak in our university is about 3 o'clock p.m., 4 o'clock p.m. because of those conditional airs. And actually, that solar plant will produce energy to about 5% of our consumption. It's very small. It's very small. Actually, we think that efficiency actions to replace lamps, to replace conditioner airs is the first and necessary step before to produce your own energy, because it doesn't make any sense to generate your own energy if you use very badly. So the idea is to use this solar plant actually as a lab. It's going to be an important lab for our students from 3 different courses. And they're also going to have the opportunity to have visits from other institutions, high school, and to stimulate people to use this technology and how to use it. to know what professionals can design these projects, and not just to hire people without good backgrounds and to do bad work in your house.
Okay, thank you.
So I'd
You're welcome.
So I'd like to invite students as well as faculty to ask questions. Professor Cavalcante.
This is Brian Park. Great talk. Thank you so very much. My question is more of policy on solar installments, any subsidies and any pattern change with that, and things seems working. Some people hesitating, it might take 5 to 10 years to break even by using solars and things like that. How is the condition in your country compared to maybe US and other countries?
In Brazil, we still can install those solar plants and to have one-to-one relation between the network electrical energy and the solar plants. But the companies are not very happy with this, because the electrical network, it's like a battery. So if you can produce all the amount of energy that you need, maybe you're gonna pay for the company a very small tax. This is the situation right now. But those companies are saying to the government and to the people, at some point, this policy to have one-to-one relation between the energy that we produce and to deliver in your house and the energy that you generate. This is not going to make any sense, because we're not going to survive. So at some point, this change is going to be necessary. So we're not going to have one-to-one. Want to have 1 to 8.8, at some point 8.6, and little by little to have, in terms of a financial condition for the companies, for the people, a situation, a more fair situation. So this is what we're discussing a lot right now in terms of government and politics about this kind of technology in the house and in the industry. But they are saying that if you install now, this is not going to change 5 years from now, 10 years from now. Even if the law changes, even if this relationship changes, you have guaranteed that the moment that you're starting this technology, we'll define how it's going to be this relationship between the energy that you buy from the company and the energy that you are generating in your house. Actually, the law, the regulation allows us to have 2 houses, and you can produce energy for the 2 houses if those houses have the same owner. So you just need to produce one of those houses. We have big companies in Brazil doing that. Pharmacy company, big solar plant, and they are not paying energy almost at all for those electrical companies around the country. But that's not going happen in the future, because those companies will not be able to survive. In terms of the politics in other countries, I don't know, but for sure, in countries as Germany, where we have a lot of solar plants installed in those houses, in those companies, in the industry, for sure in Germany, we have a different situation, because different of that, those companies will not be able to survive.
Okay. Okay. So let's continue with questions. I have a question, but my question can wait. I'd like to give the faculty opportunity to ask.
I like a lot all your presentation. Particularly, I was interested in the co-location of the solar and the agriculture. And I wonder, could you say more? Is it possible also to clean a water body or an aquifer at the same site? Is there any use of the solar to do some remediation on the environment? And maybe you said some about that already, but thank you very much.
Thank you, Jim, for your kind words about my presentation. And this is a very interesting topic, interesting project. And I'm very motivated to start work on this. I'm not from agricultural science, but we have guys with this kind of background in the project. And the idea is to use those lands to have those farms, and at the same time to generate or to create an environment in terms of humidity, insulation, temperature, with those panels installed, in a way to have even more production. Maybe, why not? Depends of the farm, of the kind of farm that you are cultivating. And the idea is very, very good, especially in those countries that we do not have big lands, because for a concentrated solar plant, you would need a lot of land, and that's not good, because you need to plant, you need to cultivate. We need farms to produce foods for people, and that would not be a good choice. So the idea is to have these two technologies there, the farm technology, the solar plant technology, and one helping each other, especially the solar plant, generating or creating a good scenarios, a good context for the farm to grow in terms of humidity, exposure to the sun. This depends of the kind of culture that what they're planting there. But the idea seems to be very, very good. Even not being an agricultural science guy, but those guys are very motivated also with this project.
Thank you.
So Marcio, Robin has a question that she asked through the chat. If you can read it, or I can let me read it out loud. So I'm curious if you have any opinions on hydrogen fuel cells. Do they belong to the renewable category? And she also noticed a campus bus in the model video and was wondering about the renewable energy relative to transportation.
Okay. We do not have a bus, electrical bus, unfortunately, but some of our universities are doing this. They are using electrical bus recharged by a solar plant, from a solar plant, and that's a very nice idea, because those buses are going. They work all day long, transporting our students and professors. So that is a very nice idea, but unfortunately, we are not to work on this right now. But I I have been in touch with some professors and research groups that are doing this in other institutions around the country. And about the hydrogen fuel cells, the idea is to use this technology to storage and to transport the energy, the hydrogen. So some of our researchers are doing this. Chemical engineer is working. A chemical engineer is working on this. And yes, you can use this technology, especially to transportate, to relocate the energy to a place to another. And that is a very good idea, to have storage and to transport that energy with this technology.
So, Marcio, can you say something about the student participation in the project? How many undergraduate students, how many graduate students, the different areas, the different disciplines?
Yeah, sure. We have 2 undergraduate students from civil engineering course. We have, at some point we had 4 students from computational engineering course, and 3 students from the energy engineering course, undergraduate. And during the project, we were able to involve at least 3 or 4 master degree students.
Yeah. So how long has this been going on? When did this project start?
We started in 2018.
18.
We have a suspension of 5 months last year because of the problems with this disease. Huh? Yeah. But we were able to restart in October, and we're going to finish by the end of this year. Unfortunately, Professor, would be a very good thing to have that solar plant built, at least at the middle of the project. But in Brazil, especially in Alagoas, we have a little problem with the company because they were in process of to sell the public to the private company, and that took a little bit. And before that, they said to us, no, we cannot invest so much money in that solar plant without solving this problem, because we need to sell to the private company before, so they can decide what to do to do with this. And we have this process done, and that was good. That private company got involved in that project. They liked the project, and they are investing now.
Yeah. So I'd like to invite students again to ask questions. Through chat or through regular microphone. So, Marcio, I have noticed in one of your videos that next to the solar panels on the rooftops of these buildings, there were also plants. So flowers or plants, so I wonder if they serve any function.
Actually, that was an architecture decision, because that kind of roof can produce a good sensation inside the the building because of the humidity, temperature, something like that. And also because of the most important source of renewable energy is biomass. So we can have those plants like saying, oh, we can also produce energy from biomass, from biofuel. And Brazil has a lot of technology developed in terms of biofuel, and from sugar cane especially.
Yeah. So Robin has another question regarding plans to integrate solar panels with hydropower infrastructure.
The idea to have a solar photovoltaic plant together with a hydropower system is very good, because most of those hydropower plants have an artificial lake with a big extension, and you have problems with evaporation of the water. So once you install those solar panels on the surface of the water, we can avoid a big amount of that evaporation. So it's a very nice idea to have both systems working together. We have some experiments in Brazil, in the Northeast, but we do not have a bigger solar photovoltaic plant in a hydropower installation in Brazil yet. But at some point, I hope we're gonna have it. And this is a very nice idea to have a solar photovoltaic system together with the hydropower, avoid a big amount of the evaporation. So we can save part of the water that's there to produce energy. So in fact, this is a very nice idea, and we have some experiments in Brazil, and I hope at some point we're gonna have a big solar photovoltaic plants together with our hydropower systems installations, because this is going to be good for both systems, because we have an artificial lake with a big extension in most of our hydropower plants, and we can use that extension of area to generate energy from a solar photovoltaic plant. So this is nice, and we are doing something, but just in terms of experiment.
So when will this project be finished?
October of this year.
And then what are your plans? What is the next project?
I'm very motivated for that Aggro photovoltaic project.
Yeah.
I really would like to do something that, and using my knowledge of structure analysis, because the structure plays a big role in that system, because it must be very high, stable, and also there are challenges in terms of safety for if you have some problems with the ways to cut those plants. So the vehicles going through those structures, and fire. That's common in Brazil. We have problems with fire. Yeah. And we need to create some system to protect the structure and the solar panels from the fire. And we have a lot of issues there. And it's a project with a big impact in Brazil, because we have a lot of lands with sugar plant farms. And if you have success we can make a big role and to pass on that kind of technology and data generating that project.
Yeah. So are you thinking about using composites for these different structures? Like, for instance, the support system for this solar panel roof?
Not initially, Professor, but I'm having some meetings with a company in Alagoas that work with composite materials. Actually, they do a lot of both using composite materials.
I see.
And they are interested to manufacture towers, and they also to manufacture a wind system with composite materials. And I have some research on this using optimization for the tower, and also for the machine itself. But still in the basis, I'm doing this with the undergraduate students yet. I did one thesis on that topic, optimization of wind tower in composites. And
yeah.
I think in terms of technology for wind towers and wind machines, I think to design those blades in composite material using optimization, we can do something very interesting on that in that area. But in terms of solar plants, I haven't thought yet about this possibility because of the cost.
Yeah.
I think it would not be an interesting choice.
Okay. We're at 3:17, a little bit past the allotted time. So let's thank Professor Cavalcante for a very interesting and comprehensive talk. Thank you so much, Marcio. Even though you cannot hear me, I'm going to release you, but I'd like to release the students, but I'd like my students to stay on.
Okay, Professor.
Okay, and
thank you very much for the invitation, Professor. Thank you very much, guys, for your attention.
Thank you, Jim.
I had such great time at UVA, and it's good to have you guys here listening to me.
Yeah.